last year, I had this, this quite exciting opportunity with a different team, and with really incredible people, which I wanted to take on. But one of the requirements was that I had to code in C#, and I've only done C++ for my working, experience was only with C++. Sure, you do hello world in different languages, but C++ is my language. So, I thought, okay, how hard could it be? I've learned quite a bit programming in C++, and it just starts with C. So I can do it. I'm sure I can do it. How hard could it be? And longest story short, it's not too hard, but there are things that I had to go and read, and things that I knew in C++, but when I saw them in C#, it didn't immediately tell me what they are, which again, concepts were very similar, and that's why I thought that I can make this talk for the C++ community that to save some time for the community. Is there something that I learned maybe it took me 1 hour to figure out what it is, or half an hour to figure out what it is, while it would only take 10 seconds to just say, hey, this is the same concept that we had in C++. So that's it. Just move on. So that's what it is. Now about me, what I can tell you is that my experience with C# is so little that I can comfortably tell you that I'm not a C# expert. But my experience with C++, it's long enough that I can comfortably tell you that I'm not a C++ expert. So just, I'm just going to tell you as much as I know. I was going to say a little bit about the history of C++ and C# and how they influence each other over time, but I don't think this is going to help the last year me, so I'm just going to skip it. I'm going to talk about things that are, very simple to learn, very quick, just with a glance, you know what it is. And then some things that are similar concepts, but a little bit different. So it's good to hear them once, and you can work with them easily. And then there's two major differences from my point of view. I'll talk about those two. So first, the minor differences. One of the minor differences is that all the code should be in some sort of class. You can't have free functions or global variables that aren't in a class, which is kind of like, if coming from C++, I would like to think that, all right, these are the things, these are the functions that they don't need to have classes, so free your functions. But you can't quite do that. You can do it with static classes and static methods, which are pretty much the same thing, but they should be wrapped within a class. Now, main used to be also a function, that's the entry point function. That used to be a function that it had to also belong to a class. Now, in the newer versions of C#, that's not the requirement. However, I think that's mostly for maybe a small programs that you may want to write and you may want to test something, then you don't put it in a class. It's still, I think, fair to say that all the code should be within a class. The other thing is that each function should explicitly mention if they are, what is their access modifier. So in C++, we group them together. In C#, we have to mention one by one. Again, not a big deal. You can read and write and no problem. Then the other thing is just very minor difference. If you see sealed in C#, it's the same as final in C++, just a different name, but same concept as final. If you have a final method in your class, there is a keyword called read only am I a little bit? Oh, okay. So sorry. So there is the concept of explicitly saying that which classes are interfaces. So in C++, we may have pure virtual functions, which make the class something that you can't really declare a variable of that type. You have to have some derived classes, and those are the things that you can have your variables from. In C#, you have this concept of interface classes, which says that everything that I have in here, I'm not going to provide any implementation for it. It's as if all of the functions in your class are pure virtual. So that's that. And then we have the concept of read-only versus const variables, or like the member fields. And the read-only, so the const is kind of just same as C++. The read-only, the only difference is that it's very similar to const, except that it would get set as runtime. So if you have something that you want to set at runtime and it would never change after you set it, that's a read-only. That's not a const. You can't use a const on it. Okay, so the other thing which I found new was partial classes. Partial classes are classes that the entire, definition of what are the methods, what are the fields, they're not all in one class. You can have in two different places that say this is it's as if you say, hey, I'm giving you part of this class, the rest of the class is going to come later. Wait for it, right? And that's when it's normally used when you have some automatically generated code for part of your class, and then the rest of the class is something that you want to write by hand, and that is not generated. So that's one of the main reasons that there are partial classes. There are sometimes I guess people use it for divide and conquer. You want to have parts of the class in one file maybe, and then another in one other file. I guess there are other reasons too, but the main reason would be just having generated code that is gonna write part of the class, but not all of it. What else? If you hear delegates in C#, that's just the same as function pointers. If you know what is function pointer, you know what is delegate. The syntax look a little bit different, but it's the same idea. And they're always, not always, they're often used just as a callback method in event handlers. Okay, so those ones were my quick differences that, just seeing it 5 minutes, you'll know what it is. Now, I like this thing. It's just, I feel like, I don't know, maybe, at least that's how I read it, that the C# developers, C# creators think they like to have things concise. Like you can see a lot of ways that you can do in C++, or you can do in C# in different ways, but then they'll give you just a method or a way to get it done quickly or concisely. And that is which is one of the examples. So if you want to copy from another variable, but you want to change some pieces of it, you don't have to copy in one line or in one operation and then change it in other operations. You can just say this is equal to that with some differences. Lambda expressions, I'm not going to really explain what they are. I'm going to assume you know what are lambda expressions in C++, but if if you want to see some more, here's one good talk from last year, which talks about like how you would use lambdas. In C#, I think it's very similar, other than how it looks. Just this kind of like the arrow operator is how the compiler knows that you're talking about a lambda. So you can say that what are the parameters? You pass the parameters that are going to go in, and then what is the return? Now here, if all you're doing is a small calculation and then you're returning it, you don't even have to write the return. Like there's an implicit return in there. But if you want to do something else, like maybe you need a couple lines of writing some calculation, maybe a function call, whatever you want to do, you can do that too, and then you need to write the return yourself. But yeah, I think these ones, the ones that don't have any return, could look quite a bit strange the first time we look at it. It's like, okay, what are we trying to do here? And that's because there is an implicit return there. Okay, this is something that I found, and I thought, oh, this is quite cool. A lot of times when we are coding, we want to have our member variables, something that we want to encapsulate them. We don't want them to be public, but then we may need to, the outside code may need to read them. So that would be us making it private and then writing a get something in our, as an interface to get that value, but then no one else can change it, right? So in C#, this is built in. It's called a property that you can say, hey, I have this member, which is not a field anymore. It's a property, and that has a get, which is a public get, and it knows how to just set it. It's just an equal, and then the set is a private. Or maybe you would think that, okay, no, I do want to set it. I don't want to let someone outside set it too. So then you can have a public set as well. Or you can have properties that the set function does something extra other than just setting. So that means that now if you have the member equals something else, in my mind, it's as if I'm writing an equal operator override for every single member, right? If I want to do that, if I have to do something extra when I receive a value, then one thing we could do in C++ is to just write an equal operator override, but then that wouldn't be just for one member. I mean, you could do that for one member, but that would be too much work. But in C#, the properties would basically do that. Now, note that in the set, there is something called the value, and that is what is passed in, or what is its equal, the right hand. That's what it is. It's just a keyword that you can assume that it's going to be passed in, and then you would do whatever you need to do with it. Now, the next couple of slides that I have is about function arguments. Function arguments is quite difficult in C++. It's complex, like when we're passing what, or how we are passing the way that we intend to pass it in, it takes a lot of thinking. Now, this is a great talk a couple years ago that talks about, okay, can we simplify it? Can we just say, what do we intend to do with this variable? And then that would, basically the compiler would take care of it. That's not what we do in C++. It's a proposal. But some of the things that are in this slide, which was proposed before, are things that C# does. So for example, if you want to pass in something by reference, you would explicitly say ref instead of the ampersand. So that's not a big deal. The other thing is that if you want to pass it by value, or it's just an input, it's not necessarily by value, but you know that it's an input, your intention is that you're going to read from it, you write in to specify that this is an input only for my variable. Now, there's another one called out, and then the out has to be set in the method before it gets read or it gets used or whatever you do with it. Otherwise, the compiler is going to tell you, hey, you told me that I have to set this saying, this function is taking a variable which is an output of it, but you're not letting me set it. So now, a good reason you want to use out variables as an argument, function argument, is that that variable that you want to set, you don't have to define it before you pass it to the function and then set it there. If it's supposed to be from the scope of like the caller in C++, what we do is that we say, let me define it. I may or may not initialize it. Now, if you don't initialize it, that's a bad practice. Who knows what's going to happen to it? If you do initialize it and set it to a dummy value, that's also not a great practice, because then we don't know, is this actually set? Do we intend it to be this value or not? So that's not a great practice either. But when you pass it in C#, if you declare it as that output variable, that's where you are setting it, and then it's going to get set inside the function, and you know that it was never set something dummy, and it's never uninitialized. So that's quite reliable. So now let's look at the ref function argument and the out function argument. Like I was telling you, the difference, I guess, here, just want to emphasize that the out function argument, you cannot assume that it's been set before. You cannot read or modify it before it's been set. A ref, that's something that the intention is you can change it, but it's been out and the outside code has taken care of it. So that's the main difference between the two. Another thing about the function arguments is that I remember the first time I tried, like passing, a read-only value, and in my mind that has to be a const. I know I'm not going to change it. Put a constant. It's not compiling. And I'm like, what the heck? What kind of language doesn't have const? And then I realized that okay, an in argument is always by default a const value, so you can't really change that. So. Now, this one is kind of sweet. It's not something essential to the language, but I kind of like it, so I thought that I'll just going to talk about it. So these are called extension methods, that they are meant to extend the functionality of something that either you don't have access to that class, or maybe it is your class, but you don't want to change it for everything else. So the idea is that you can add functionality to a type without actually changing the implementation of that code. And this is how it works. It says that, hey, if my function, which is a static function, it has to be static. The argument says that it's this argument, so it's a this type name. That means that I'm extending that functionality of that type. So now later, it works as if this was defined within that type. Again, one of the good examples is that you are using maybe a library, and you want to add some functionality to it. You don't even have access to that code. So one way to do it, obviously, that's what we do in C++ too, is to write a method and say that this thing, I'm going to pass it in as a reference. You make the changes that you want to it, and then just return me whatever it was, whatever the result of that function is. You can do the same thing here, but this is, it's rather just syntactic trigger, but it's kind of make it easier to read the code and kind of make it concise. So that's nice. Also, a benefit of this is this, that your IntelliSense or whatever that you use, when you do that, it's going to show that as a list of methods that are available for you to use. So you can see that, oh, okay, this is the thing that I need. So I'm just going to call it. Okay. Now, ternary operator, we have them in C++. There is a question mark, and then, we've seen this, and I knew what this is going into C#, but then I saw a bunch of other examples with question marks in them, and didn't know what they are. Like, what does it mean? And I had to do a lot of research. While these are not really complex topics, they're just a different syntax. So let's go through them. This one is, the first one is a nullable. Nullable is just a different name that they use in C# for optional. So if you know what's optional, you know what is this int question mark. Called nullable, think of it as optional. This one is interesting. It has too many question marks. So what does this one mean? The first one says that, okay, if I have a nullable, it may or may not be assigned, something be assigned to it. Do I know it is or not? So that says that if, so it's called a null conditional operator. If it is, then let's call, either read it or call a function on it or do something, but don't do it if it's null. And then the second one says that, okay, if that whole thing turned out to be null, let's do something else. Let's not assign the null to it. This is probably what we would do in C++. We would check first to make sure that maybe a pointer is not null, and then can I get the next on it or whatever function on it? If that is also not null, now let me call it. If one of those things is null, now let's call something else. Okay? So that's what it is in one line. Again, if you get used to it, it's kind of nice. And then this one is related. Here we have exclamation points, and that is to assert to the compiler that I know what I'm doing. This is not null. Don't complain that this may be null. So that one here is, I have a nullable, and for whatever reason, I am confident that my code, when it gets to my code, it's not going to be null. So that's a null forgiving operator, and it's telling the compiler, just assume that this is not going to be null. There are more cases, but I'm not going to cover all of them. Here is a really good talk that goes for 1 hour, 1 full hour, just talking about different ways of, different syntax or different meanings to each of these question marks, which is good, Okay, now in C++, if we have a hierarchy and then the base class has a function that is not a virtual function, the derived class can have a function with the same name, and they can basically hide the base class function, which may or may not be intended. Maybe it is, or maybe the programmer didn't know that this thing already exists, and I'm overriding it, and now it's going to be super confusing. In C#, if you write a code like this, there's going to be a warning that says, this is hiding your base function. Are you sure you want to do that? If you do, call it new. Use the new keyword. So the new keyword, you put it on a function, it is not a virtual function, and you want to hide the base, that's the thing that would explicitly say, yeah, this is not, I intend to hide the other function. All right, so generics, I think that's pretty much what the templates are called in C#. However, they are not. So I say it this way. If you know templates in C++, you have no problem reading and understanding generics in C#. However, in C#, generics aren't as flexible and as powerful as templates. So there are some limitations. They are, if you're very good at templates, you might find it a little bit frustrating that things that you can do with templates in C++ you can't do in C#. But at least reading and writing them are not, it's very intuitive. So some of the differences, I haven't listed everything here, is that there's no support for partial specialization, which is a big thing, I feel. And then the type parameters can't itself be a generic. Again, that's a big one. I would say there are a lot of cases that we may need that. The non-type template parameters, like int, you can't have them as a template parameter. And then there are some other differences and limitations compared to templates. I'm not going to talk about concurrency because it's a big topic, but all I want to say is that it's, at least compared to C++ from a couple years ago, the code that, maybe we've all learned concurrency with, I would say it's much easier to write concurrency on C# with there are await and async patterns, and then there's returning tasks, and those things kind of make it easier to read and understand that the C# concurrence code. Although C++, we're adding these things into the library, so that's kind of nice. But yeah, I mean, if we want to learn concurrency, that's a couple of topics. Okay, now, what is, there are two major differences that I want to talk about. One of them is this piece of code that when I saw, I was quite shocked at how is this possible that you're saying, there is a class and then inside it I have a member, not a reference, a member of that same class. So check and double check, and how does this even compile? And here is a big, big difference between C++ and C#, and that is that classes in C# are reference types, right? In C++, when we think of classes and structures, they're pretty much the same, right? Maybe we have some conventions to say, okay, this is where you use structures, this is where you use classes, or just really, really minor idea, at least, But in C#, there is a huge difference. And that is that, structures, they own their data, they are value type. Classes, just nature their reference type. They don't own their data. So I'll get to the rest of it. So, and then, in my mind, which was trained with C++, when I see new, I think that's a data on heap. But in C#, that's not the case. You see it new, and it could be very much on a stack, because if it is a structure, that's going to be owning data on a stack. If it is class, that's going to be just a reference, and it's going to be on a heap. So that's a huge difference, and it takes a while to, just get used to it. Now, let's quickly look at this example. I have a class, and I have a structure, and okay, so it's just a little bit of code to say, let's see if I pass in, the structure and the class, what's going to happen, which one is going to change, and you can just stare at the code a little bit, and then you can see that, oh yeah, okay, the class will change, even though it looks from my, my eyes are trained with C++, so I look at it, I think this is passed by value, but it is not, because it's always a reference. So in this particular example, the thing that is C that is being passed in is going to change, but the other one, that is the structure, that's not going to change. So to me, that was a big difference. And then, I saw code like this, and knowing that, okay, the classes are reference type. Now, this is not very concerning. If you think with your C++ hat on, you would say, wait a second, why are we passing this big class in without having the ampersand or, cons and or whatever? This, like, why are we copying this big thing? But then knowing that, no, this is a reference type, then this is not concerning anymore. You understand that this is by default just a reference. Now, the downside is that if you pass in something which is a class, you have to make sure that it could be null, so you have to check for it, right? You can't assume that a variable that is passed in that looks like this it's going to have the data. It may be null, so. But the compiler helps, right? One of the things that I did and kind of helped me to remind me that which one is a structure, which one is a class, is that I color code them with the, like their options that in Visual Studio that says, hey, just change the colors if it's this type or that type, and that kind of reminded me constantly what I'm looking at. Is it a class or a struct? Now, another big difference is that the memory management, right? In C++, we spend a lot of time thinking about the scope. What happens? What am I gonna do when this thing goes out of scope? Do I have to do anything special? Am I okay to just, let the default destructor take care of it? What are we doing? Or the dangling, references. That's a big one too, right? In C#, C# has garbage collectors. So there is reference counting. So if something else is referencing it, it's not gonna go, it's not gonna die. It's not the garbage collector is not gonna kill it. It's not a garbage anymore because someone else is pointing to it. And that there are, it's just a different way of thinking. I can't say it makes it easier or harder. It's just very much different way of thinking about your data. In C++, there are times that we think about the destructor, or how can I use, there are ways to use destructor other than resource management. Like the main reason we have the destructors are resource management. But maybe it's not a resource management. Maybe I want to do something else when this thing goes out of scope. You can't do those sort of things in C#. There is something called the finalizer that you can write, but that's not exactly a destructor. And also you can't call it yourself, and you don't know where, when or where it gets called. It's good if you have some external resources and you want to take care of them and you want to make sure that it does take care of, is being taken care of. But again, it's not exactly the same way as we think about constructors. There's another thing which is called dispose, and that is if you want to take care of some stuff, some resources while your variable goes out of scope. Now, I have to be careful. It's not really about the scope. It's about whenever it gets disposed, which may or may not be at the same time as it goes out of scope. So you can say that my class implements iDisposable. And again, it is not a destructor. You can call it manually, and you can decide when it gets called. Okay, but again, you can do whatever you need in the dispose function. And that I can't emphasize more that when we call dispose, it doesn't mean that that variable is killed or it's it's just whatever you do in that function is going to get called. But there's some nice things about dispose. There's this keyword called using, and if you declare a variable within that using clause, then that is guaranteed that after it is at the end of using, it is going to call that whatever resource that you have dot dispose, and you don't have to write it; it gets done automatically. So that's the pattern that people use if they want to make sure that whenever I don't need this resource, these are the things that I want to be done in dispose. They use using. Now there is another pattern that people use with dispose, and that is the try catch finally. So we have the try catch in C++. We write it, and we have our code. If something happens that we need to throw, we throw, and then we do the catch. We handle the error, whatever that is. That's fine. In C#, we have something in addition that is finally. And finally says that, hey, if I'm getting out of this function, or this not necessarily function, in this try catch finally block of code, then make sure call these things that I'm writing in finally. So it could be dispose, it could be something else, it could be just a log, whatever that is. So that's also a very useful pattern to say that it could be around a function, or it could be part of a function, but whenever that is done, let's call dispose or do something else. And again, when I think of how I wrote my specialized destructor, I probably wanted to do something more like this, right? That was my intention when I code in C++ and I write a specific destructor to do something. That's probably one of these cases that there is an error, and I want to make sure that no matter what, if it goes out of scope, I want this thing to be done. So that's the pattern that gets used in C#. There are other things that I feel like it's if you happen to work on C# and you don't know, I think they're good to take a look at them and do quite a bit of reading on them, but they're too big to fit it in this talk. So I just thought that I'm just going to list them for anyone who might be interested. And that is my talk. Thank you so much for listening.